Hello friends, I Professor Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for this subject head network theory. So friends, as far as our today's session is concerned, so we will try to learn another important aspect of this network theory terminology whose name is nothing but what? The Supermesh analysis, right? So with the help of this very simple example, we will try to learn this circuit analysis technique whose name is nothing but what? The super mesh analysis, right? Now when we compare the super mesh analysis with an ordinary mesh analysis system, so at that time we will come to know the difference in between these two terminologies, right? Because as far as this mesh analysis is concerned, so in case of this mesh analysis, that given particular network, we do can analyze or we do can realize that given network in terms of certain circuit parameters. So for that purpose, what we need to do in case of mesh analysis, already I had given one or two examples based upon this mesh analysis technique in that previous lecture, or at the end of this lecture I will try to provide the link for that previous lecture, so you can go through that previous lecture. So first of all, we need to identify how many number of the closed circuit or the closed conducting paths we used to have within that given network. The closed conducting path is nothing but what? The mesh, what we can see, right? So similarly, in case of this super mesh analysis, first of all, we need to understand our objective is to determine the desired current flowing through this 2 ohm of resistor, right? So from mesh analysis point of view, when we will try to look around this given network, so at that time we will come to know that there are three identical mesh we are having with us, right? So this will be the first one, and the current flowing through this first mesh can be called it as I1. Obviously the current flowing through this second mesh I2, and this will be I3, right? Now it's up to we people ki how the direction of this mesh currents are to be assumed, right? So probably there are two ways by which we do can make this assumption ki either the direction of branch currents are clockwise or anti-clockwise. But every time, as far as my knowledge is concerned, so always I prefer to consider this clockwise direction for the simplicity of that network. So as you can see, I1 is clockwise, I2 is also clockwise, and I3 is also clockwise. So similar to that mesh analysis, when we apply this Kirchhoff voltage law, right? This KVL is nothing but what? Which says that the ohmic drop of all elements which are associated with that close conducting path are equated to 0. Their ohmic drops are being, or the algebraic sum of ohmic drop belongs to that close conducting path are equated to 0. This is the basic logic behind this Kirchhoff voltage law, right? So when we apply this Kirchhoff voltage law to that first loop, just similar to that previous method, so at that time our equation will become what here? When we apply this KVL to mesh number 1, right? So at that time, first of all, carefully we need to look around ki how many number of elements we are having within that mesh, right? So this is how our network will look like. In this network, finite number of resistive elements we are having with us, right? Finite number of energy sources we are having with us. Energy sources means voltage source and current source, right? Now another important thing which we need to understand ki there are two types of energy sources which are generally located in this AC or DC network. So these two energy sources are nothing but the dependent and independent energy sources. Now as far as this network is concerned, so within that network we are having one voltage source and we are having one current source, right? But these two energy sources are independent energy sources because they are not depends upon any particular element or any particular current or voltage which is present into that circuitry. That's why these two energy sources can be called as a independent, right? So next after that, what we need to do within that mesh number 1, how many associative elements are there, because we need to apply this KVL to that mesh number 1. So within that mesh number 1, we are having one battery of 50 volt. After that, these two resistors we are having with us. One is of 10 ohm and 5 ohm. But the unique identities belongs to these two resistors is nothing but what? Actually, these two resistors are connected in vertical arm, right? When we are talking about this 10 ohm resistor, so within this 10 ohm resistor, there will be a circulation of I1 as well as I2. In same manner, as far as this 5 ohm resistor is concerned, again it is associated with that mesh number 1 as well as mesh number 3. So obviously there will be a circulation of branch currents belongs to mesh number 1, I1, and the branch current belongs to mesh number 3, that is nothing but what? I3, right? So that we need to understand. Once we are coming on to this conclusion key, there are three identical elements within that first mesh. How the desired current flows through these two resistive elements, that we need to understand, right? So the assumed direction of I1 is clockwise, right? So this when we are saying that this I1 flows in clockwise direction, as this 10 ohm as well as 5 ohm resistors are connected in vertical arm, so obviously this I1 flows through these two resistors in this way from top to bottom, because the current or the direction of current is nothing but what? Which is always opposite to the flow of electrons. Always electrons flows from negative to positive terminal. So the direction of current is always from positive to negative. So in this way, this I1 flow through this 10 ohm resistor. Accordingly, we need to mark the polarities. In same manner, this I1 flow through this 5 ohm resistor from top to bottom. As I told you earlier, these two resistors are connected in vertical arm. So along with this I1, there will be a circulation of I2 through this 10 ohm of resistor. Now the assumed direction of I2 is clockwise, right? So how this clockwise current flow through this 10 ohm of resistor? Obviously from bottom to top, right? Means one interesting thing which we need to understand while applying this Kirchhoff voltage law, what we need to do, we need to map the ohmic drop across this resistor. So according to this Ohm's law, V equals to I into R. Now through this 10 ohm of resistor, there will be a circulation of I1 as well as I3. How I3 flow through this 10 ohm of resistor from top to bottom, and how I1 flow through this 10 ohm of resistor top to bottom, and how I3 flow through this 10 ohm of resistor from bottom to top, right? Means their circulating directions are opposite to each other. That we need to understand while applying this Kirchhoff voltage law to that mesh number 1, right? Now same thing happens in case of this low resistor, which is of 5 ohm. Through this 5 ohm resistor, I1 flows from top to bottom, and this I3 flows from bottom to top. Again, their directions are opposite to each other, right? So when we start our journey with this 50 volt of battery for this Kirchhoff voltage law, so at that time, see, this is the negative plate and the upper one is positive plate. So as we need to follow the direction of assumed current. The direction of assumed current is clockwise, means as far as this 50 volt battery is concerned, we are going from negative to positive plate. So opposite polarity we need to consider. So it will become plus 50. After this, the ohmic drop across this 10 ohm of resistor. As we are going from positive to negative direction, opposite sign we need to consider minus 10 times of which two current flow through this 10 ohm of resistor? I1 as well as I2. How I1 flows top to bottom and I2 flows bottom to top. That's why as the direction of current this through this 10 ohm of resistor belongs to this I1 and I3 are opposite to each other. That's why we need to consider the negative sign. In same manner, while mapping the ohmic drop across this 5 ohm of resistor, closely we need to follow the direction of assumed current. Assumed current is in clockwise direction, means we are going from positive to negative plane. That's why opposite sign we need to consider. Ohmic drop across this 5 ohm of resistor will be minus 5 times of I1 minus I3 equals to 0. Right. So in this way, this Kirchhoff voltage law is being applied within that first mesh. with respect to these three elements. One is energy source and two are the resistors. Out of these two resistors, within that first resistor, there will be a circulation of I1 and I3 here. I1 and I2. Right. By mistake, it was I3. It was written like I3, but which term we need to consider? Through this 10 ohm of resistor, there will be a circulation of I1 and I2. So 10 times of I1 minus I2, and through this 5 ohm of resistor, I1 minus I3. Then after that, we need to simplify this statement. As a result of simplification, it will become 50 minus 10 I1 plus 10 I2 minus 5 I1 plus 5 I3 equals to 0. So this equation will become minus 10 minus 5 minus 15 times of I1 plus how many I2s we are having? Only one, plus 10 I2 plus 5 I3, and this 50 is being shifted to this right hand side of this assignment operator. As a result of shifting, it will become minus 50. So this will become our equation number 1. Right. Now next, at this moment we will come to know the significance of this super mesh. What do you mean by this super mesh? Right. So when we apply this Kirchhoff voltage law to that mesh number 2, at that time we will come to know ki there will be obviously a current source of 2 ampere is associated with mesh number 2 as well as mesh number 3. So whenever we are having such kind of situation in which if the multiple number of mesh or loops are sharing the similar current source, at that time such type of scenario can be called it as a super mesh, right? Because it is not possible for we people to apply the Kirchhoff voltage law to loop number 2 as well as loop number 3. What is the reason behind that? Because they are sharing the similar current source of how many ampere? Of 2 ampere. So it is not possible for we people to apply the Kirchhoff voltage law to this particular element which consists of this current source of 2 ampere. So at this moment our objective is what? Our objective was to determine the current flowing through this 2 ohm of resistor. So in order to complete our objective, this super mesh strategy we need to follow, right? Now while following the super mesh strategy, what we need to do? See, as I told you earlier, in this horizontal arm we used to have this current source of how many ampere? A current source of 2 ampere and a resistor of 3 ohm, right? Then after that, this is how our circuit will look like. These two resistors are there. This is of 10 ohm, 5 ohm, 2 ohm and 1 ohm. This is the 2 ampere. This is I2 and this is I3. Now super mesh concept is nothing but what? Virtually when we remove this branch which consists of this current source as well as this 3 ohm of resistor, right, means virtually this branch is being eliminated, and as a result of elimination the remaining whole thing can be called it as a super mesh, right? Now while considering this super mesh, one important thing which we need to understand, when we apply the Kirchhoff voltage law to this super mesh, so at that time these two branch current will retain its position as it is. Means through this 10 ohm of resistor there will be a circulation of I1 as well as I2. Through this 5 ohm of resistor there will be a circulation of I1 as well as I3. Means even though this branch is being eliminated, these two current will retain its identity. So by taking into account this fact, now we need to apply the Kirchhoff voltage law to this remaining circuit, that can be called it as a super mesh. So as a result of this, see, when we start our journey with this 10 ohm of resistor, right? So as I told you earlier, even though it is a super mesh, but it will maintain the position of I2 as well as I3. How I2 flows in clockwise direction, how I3 flows in clockwise direction, right? So initially while applying this Kirchhoff voltage law to that mesh number 1, already it is being considered ki how I2 flow through this 10 ohm of resistor from bottom to top, right? Because the assumed direction of I2 is nothing but what? Clockwise, right? So when we apply the Kirchhoff voltage law to this super mesh, at that time how many elements we are having? At that time we are having total 4 resistive element, 10 ohm of resistor, 2 ohm, 1 ohm and 5 ohm. But while obtaining the ohmic drop across this 10 ohm of resistor, so through this 10 ohm of resistor there will be a circulation of I1 as well as I2, and their current directions are opposite to each other. And how I2 flows through that 10 ohm of resistor from bottom to top, and closely we need to follow the direction of assumed current while applying this KVL. So as we are going from positive to negative plate, we opposite sign we need to consider, so it will become minus 10 times of. Now when we are applying this Kirchhoff voltage law to this super mesh, so at that time the significance of this I2 is greater than I1 as well as I3 is greater than I1, that we need to understand. So by taking into account this fact, the ohmic drop across this 10 ohm of resistor will become minus 10 times of I2 minus I1. See, this is the first element into that super mesh. Second element is what? This 2 ohm of resistor. So through this 2 ohm of resistor there will be a circulation of this I2. How I2 flow through this 2 ohm of resistor? By considering this clockwise direction, top to bottom, right? Top to bottom. So closely we need to follow the direction of assumed current. So again we are going from positive to negative, means minus 2 times of I2, right? As far as this 1 ohm of resistor is concerned, so through this 1 ohm of resistor purely there will be a circulation of I3. How I3 flows? Again top to bottom, as we need to closely follow the direction of assumed current, so it will become minus I3, right? Because purely I3 flow through this 1 ohm of resistor. After that the remaining element is nothing but what? This 5 ohm of resistor. So through this 5 ohm of resistor there will be a circulation of this I3 as well as I1. But when we are in super mesh, so at that time this I3 is greater than I1. So how I3 flow through this 5 ohm of resistor? The assumed direction of I3 is clockwise, so bottom to top. Closely we need to follow the direction of assumed current, means we are going from positive to negative plate, so opposite sign we need to consider. So it is minus 5 times of I3 minus I1 equals to 0. So this is how the statement will look like. Then after that we need to simplify, so it will become minus 10 times of I2 plus 10 I1 minus 2 I2 minus I3 minus 5 I3 plus 5 I1, so it will become equals to 0, right? So finally our equation will become what here? This minus 10 will get multiplied with this parenthesis, so minus 10 I2 plus 10 I1 minus 2 I2 as it is minus I3 as it is. This minus 5 will get multiplied with this parenthesis. As a result of this, minus 5 I3 plus 5 I1. So how many terms we used to have belongs to this I1? This 10 plus 5, 15. 15 I1. How many terms belongs to this I2? This 10 minus 2 minus 10 minus 2. So totally it will become minus 12 times of I2. And how many terms we are having belongs to this I3? This minus 1 and minus 5. So minus 6 I3 equals to 0. This is our equation number 2. Right. Now one more equation here we need to write. So while writing this equation according to this given network, see, this is how this 2 ampere of current source is associated with this mesh number 2 as well as mesh number 3. But carefully when we try to look around to this network, so the direction of this assumed current I2 is clockwise, and the original direction of current belongs to this 2 ampere of current source are in phase with each other, means they are sharing the similar direction. But as far as this I3 is concerned, so the direction of I3 and this current source direction is opposite to each other. So by taking into account this fact, the third current equation will become what here? I2 minus I3 equals to 2 ampere. So this is our equation number 3. So as we are having these three equations, then after that we need to solve these three equations with the help of this scientific calculator basically, and then we will come to know कि I1 and I2, I1, I2 and I3 equals to what, and then after that we too can decide our objective कि current flowing through this 2 ohm resistor is how much. Okay friends, so these three are the equation. First one is minus 15 I1 plus 10 I2 plus 5 I3 equals to minus 50. Equation number 2 is I2 minus I3 equals to 2. And equation number 3 is 15 I1 minus 12 I2 minus 6 I3 equals to 0. So when we enter these three equations with the help of the scientific calculator, so we need to go to that equation mode. As we are having equation mode, we are having three variables. Then after that, one by one we need to enter the coefficients. So the first coefficient, equation number 1, minus 15. Then the second coefficient is 10. Then third coefficient is 5. D1 is minus 50. Equation number 2, coefficient I1 equals to 0. B2 equals to 1. C2 equals to minus 1. And D2 equals to 2. Coefficients of equation number 3, 15 minus 12, and C3 equals to minus 6. D3 0. Then X equals to 20, means I1 equals to 20 ampere, I2 equals to 17.13 ampere, I3 equals to 15.33. So our objective is to determine I2 ohm. So this current flowing through this 2 ohm resistor is nothing but what, 17.33 ampere. Okay friends, so after solving these three equations with the help of this scientific calculator, I1 equals to 20 ampere, I2 equals to approximately 17.33 ampere, and I3 equals to 15.33 ampere. So our objective was to determine the current flowing through this 2 ohm of resistor. Now as we will come to know कि there are three mesh, so there are three mesh currents, I1, I2 and I3. All these three mesh currents are being tabulated with the help of the super mesh analysis terminology, right? Whenever any particular current source associated with multiple number of loops, so at that time, in order to realize this circuitry, this technique is being used, whose name is nothing but what, the super mesh analysis technique, right? So as we know, through this 2 ohm of resistor, there will be a circulation of I2 only. It has nothing to do with this I1 as well as I3, right? If it is connected somewhere in between these two loops, so at that time we can say that through this 2 ohm of resistor there will be a circulation of I2 as well as I3. Now for sake of moment, if suppose we are interested to determine the current flowing through this 10 ohm of resistor, right? So through this 10 ohm of resistor there will be a circulation of I1 as well as I2. So how to decide the current flowing through this 10 ohm of resistor? For that purpose, I1 equals to 20 ampere and I2 equals to 17.33 ampere. So generally the larger current will get subtracted from that smaller value. So 20 minus 17.33, like this, right? But as far as this 2 ohm resistor is concerned, so purely it is associated with this I2. So current flowing through this 2 ohm of resistor is nothing but what, 17.33 ampere. So this is how that given network is to be realized with the help of this super mesh analysis, right? So I just hope you had understand all these things regarding to this super mesh analysis. If you are having any doubt, so please try to put up your valuable suggestions and comments in that comment box. Thank you.